Hello, math humans. We're going to do 8.1 today. We're going to be continuing our discussion with matrices and systems of equations. Our objectives are that we're going to define matrices and their components, and then we are going to solve systems of equations using our REF. That's an S in case you can't tell. So for a matrix, it can be either rectangular, that's a hard word to say, or square. It doesn't matter which, but it is basically just a way of organizing data. So that's one of the reasons that we use matrices. So let's say I have a matrix that's A11, A12, A13, B11, B12, B13. Oops, sorry, bad math. B21, 22, 23, and then C31, C32, and C33. Okay? So if you'll notice, these are the rows. Going across is a row, and then going vertically is a column. Okay? Because columns support buildings, so they stand straight up and down. Rows are like when you go to the movie and they go straight across. When we talk about the size of a matrix, it is always row by column. So for this particular matrix, it is a 3 by 3. It is a square matrix. I'll pick this one. This is each of the elements inside have an address, and it tells where they are located in the matrix, and that address is always row and column. So for example, our C32 is going to be row 3, column 2, and that is that term's specific address. Okay? All right, so we're going to do some math on matrices in this chapter, but right now we're going to go back and continue our conversation about solving systems of equations. So for example 1, I want to solve this system. Okay, so I have x plus 2y plus 2z plus 4w is equal to 11, and then 3x plus 6y plus 5z plus 12w is equal to 30, and then x plus 3y minus 3z plus 2w is equal to a negative 5, and 6x minus y minus z plus w equals a negative 9. So we've talked about this before, but we're going to go ahead and talk about it again. There are lots of ways to solve matrices. It is really fun, nerdy fun, to do it by hand, and it would be using row operations. And those are really cool and fun to do, but unfortunately that is outside of our curriculum. So we are going to focus on solving this system with a matrix. So I'm going to drop all of this information into a matrix. So this is 1, 2, 2, 4, and then 11. Technically, this is going to be called an augmented matrix because the solutions are inside the matrices. And then I'm going to have 3, 6, 5, 12, 30, and then 1, 3, negative 3, 2, negative 5, and then 6, negative 1, negative 1, 1, and negative 9. So the thing that we would need to remember is if one of those numbers is not in, if there's not an element for that particular row or that particular variable, we would put in a 0. So I'm going to go to my matrix, second matrix, and I'm going to edit. I always edit A just to make my life simpler. And then it is a 3 by 3. Oops, I lied. This is a 1, 2, 3, 4. So this is a 4 by 1, 2, 3, 4, 5. This is a big old honkin' matrix. It's a 4 by 5. And so now I'm going to enter 1, 2, 2, 4, 11, 3, 6, 5, 12, 30, 1, 3, negative 3, 2, negative 5, 6, negative 1, negative 1, 1, negative 9. And I go back in and check my data entry because if you screw up your data entry, everything else is going to be bad. So I have 1, 3, 1, 6, 2, 6, 3, negative 1, 2, 5, negative 3, negative 1, 4, 12, 2, 1, 11, 30, negative 5, negative 9. Then I'm going to quit. I'm going to go back to my matrices, and then I'm going to go to Edit, Math. And remember, I want to go down, and I want to do RREF, not one REF, but I want to do RREF. I'm going to hit Enter. I'm going to tell it to go back and use matrix A, and there are my solutions. And so I'll write those down on the next page. So I get X is equal to a negative 1, Y is equal to 1, Z is 3, and W is a positive 1. Okay? And then I would write those X, Y, Z, W is equal to negative 1, 1, 3, and 1. And that way they are in ordered pair notation. Alrighty? So matrices are really helpful when we are trying to solve a system of equations. I'm very sad for you guys that I'm not going to continue doing work with row operations. But that's it for today. Lucky dogs, that's a nice short video. I will see you soon.